and you handle incoming requests, and you return responses. But we'll get that in a sec. Let's show, let's show Node in action. How's that font size for you guys? Good?
Fine.
All right, cool. So I'm on a Mac, but this Node also works great on Windows, as of maybe like a few months back, half a year back, something like that. You can see I'm running 0.6. So at the basic level, you type Node and you enter a REPL, like an interactive command line thing, and this is just like a JavaScript shell, right? So, hello, what's the type of 5? It's numbered. So this is just a straight JavaScript shell. I can create a function f that says return 10. And now f is a function. If I can call it toString on it. I can call it not f but f. So that's Node. You can also okay, I do a lot of CopScript stuff. I'll try to stay away from CopScript mainly here. Okay, perfect. So here is, if I go to lib, here is some JavaScript files, so I can run JavaScript files. This one doesn't output anything, it's a library. But I could have run this other thing that outputs some strings, right? Some output. But so that's basically Node. It just executes your JavaScript files. It runs on V8, which is the same engine that Chrome uses. So it's really fast, pretty modern, has a lot of great features. And like I said, it adds some APIs for doing stuff beyond what you might be able to do in a browser. So the most interesting one for this case maybe is HTTP, and in fact the Node.js homepage has an example of this. So the way you include modules or whatever Node is this common JS paradigm called requires, and you require it into the name of the module. It's kind of like Python's import, but it doesn't import anything into your namespace. It only gives you back an object, and you have to save that object to a variable. So in this case, we're saving the HTTP module to a variable called HTTP, and then it has some functions, one of which is create server. And so here's where we get into some interesting stuff. So here's what this function looks like. HTTP create server. It takes a function that is called whenever there's an incoming request to your server. So you give it that function. We'll get to that in a sec. And then you call .listen on it. You can give it a port and optionally a host name. And unlike like if you were writing like a Java event-driven server or like a Python thing, that listen call would be synchronous. Like it would enter the loop and it wouldn't return until you exited the loop. But in Node, there are almost no synchronous APIs, particularly for network stuff. You can't do anything with the network synchronously. Everything is asynchronously. So I'll quickly explain that in just a minute. It's who all of these use JavaScript here in general, like on the browser? Okay, cool. So you guys are generally familiar with JavaScript language. One thing you know about using JavaScript in the browser is there's no, you don't ever say like, I'm not sure. Okay, AJAX requests. They're not synchronous, right? AJAX requests are asynchronous, and you specify callbacks for like success, failure, whatever, right? But even further, JavaScript's language is optimized for event-driven stuff. So like, you register click handlers and DOM-ready handlers, and this checkbox is focused handlers. And so you write your JavaScript in a very event-driven way. So Node's kind of similar. You don't do anything synchronously. You just write functions to handle events. And so the most basic event here is that there's an incoming request. And so that's the function that the create server method takes. It says whenever there's an incoming request, I will call your function. I'll pass the request object and a response object. Sorry, I have to do this manually just for some reason the keyboard. I got a spam Twitter follower screen. I'm just kidding, I don't know if it's right. It might be legit. Alright, so we'll start with this. And so this is a file called server.js. And so if I do node server.js, you see it immediately logs that line. And now if I go in the browser and, oops, HTTP localhost colon 13.13.7.
Just do 127. That's it.
Oh, I have to, yeah, you're right. Sorry, I missed that. Thanks for that. That server, that call, specified host name, so I have to use that host name. Okay, so basic, right? Cool. So that's pretty simple, but obviously no one does hello world apps. What's going to be typical here is you're going to maybe read a file from a disk, but more likely you're going to hit a database, right? You're going to make a network request to a database, fetch some things, whatever, and then return that. So none of Node's APIs for those things is synchronous. So I'll show you some examples. So we went to the docs, and we'll look at HTTP, and we'll look at, so these are server things. Let's say we look at http.get. Let's say we just want to make a simple GET request to query something. Maybe it's our database, maybe it's some external third-party service. So this is the same thing. This is not synchronous. You give back, you pass in a callback that takes the response as a parameter, and it gets invoked by Node when the response happens. And you can also give it an error handler, right? And so this is actually a very common convention within Node. So not just HTTP. Let's say you want to quickly run a shell process, right? So you might do process.spawn. Sorry, that's a child process. So you might want to spawn a child process. Well, same thing here. You see it's all very event-driven, right? Whenever there's data, you handle it. There's no synchronous like execute, for example, get status or whatever. You have to make a child process. You have to register event handlers. So it can get pretty cumbersome. And so if we look at a pretty typical example, so let's say we wanted to, we get an income request. Let's say we want to look up the user. First of all, we want to authenticate the user, right? So we'll look at the cookie. We'll look at some unique cookie identifier, session identifier, whatever you want to call it, from the request cookie. Then we want to hit up our session store to get the session object, right? And then that'll probably have a user ID associated with it. So we want to hit up our database to get the user, the current user that's logged in. And then we want to handle the request. The request might be they want to delete a particular comment that they posted on a footer, right? So first of all, we want to validate that the comment is there. So we might make a DB request to get the comment, and then validate like they own that comment. Maybe we need to do some processing, and then we want to make another HTTP request, delete that comment, and then we want to return the response. So here's what that might look like at a high level. In just pseudocode, right? We're gonna make the first request to get the session object, and let's say we get the session back. Then we're gonna, let's say we pass in the session ID there, and now we want the user for that session.
Hey, excuse me, Hassan.
Yes.
Is function a keyword, or is that just a stand-in for a function name?
Function's keyword JavaScript. Mm-hmm. So we have the session ID from the cookie. We get the session object for that. Then we want to get the user for that session. And then we want to get the comment and then if the user owns that comment, then we want to delete that comment. And here's where we're finished. Send response, right? So you can see already there's this indentation pyramid forming. People call it a callback pyramid. And there's actually a lot more to this that's not being shown. So, for example, this could fail, right? Maybe your session server went down. Maybe your network went down. So if this was synchronous, we could just try catch that. But it's not synchronous. So the common convention in Node land is that the callback functions, they always take at least one parameter called error. And that's set to null if there was no error, but it's non-null if there was an error. And so what do you do if there's an error? Well, if there's an error, then you want to send a 500 response, and you want to return. You don't want to proceed if there's an error, right? Same thing here, right? Same thing here, and same thing here. So we're going to be duplicating this code in a bunch of places, right? So, sorry?
Is there a neater way to do that than cut and paste with the duplicate code? Or?
Yep, and that's exactly the problem. That if you're new to Node, this is what you'll run into. And you'll run into bugs where oops, you forgot to return in one case, and now even though there was an error, you went ahead and tried to do something with it, and your application crashes. So that's one problem. Another thing you notice is that, or you might notice, is we can get the comment. Let's say the comment ID was part of the URL. Like maybe this is an API request, right? We can probably get the comment in parallel with the user. So, but we can only delete the comment once we have both things. So how do we do that? I'm not sure yet, but for sure we know we can do something like this, where we make the comment request in parallel with the user request. So we'll probably want to set a flag like user finished is true, and that should be set to false up there. Comment finished will be true up here. And then we'll want to have some function proceed, which, if user finished, then proceed. And we want that here also, that if comment finished, then proceed. And that's how we kind of wait for two branches to finish, right? And so really quickly, we've added a lot. Yeah.
So it knows you need both of those somehow?
Yeah, because you don't know which one will finish first, right? We might get the user before we finish getting the comment, or vice versa.
Oh, but you're doing, if either one comes back, you proceed. When either one comes back.
Oh, sorry, the intent was to do if one both are finished. So user finish will be false at first, and when this is finished, it'll accept the true. If comment's also finished, then it'll proceed, otherwise it won't. Something like this.
Okay.
But yeah, really quickly, you can tell there's a lot of room for bugs here, right? We very quickly added a lot of bug code, and this is still not as robust as it could be, right? Because the reality is you're going to want to have common code for these error cases, and you might want to do cleanup. That if there's an error, maybe we should do something here that to kind of roll back something we did earlier, right? So this is where it gets really complicated really fast, and so there's obviously, people have built libraries for these kind of things. Here's two of the most popular ones. One is called async, by its name. And so what it does is it just provides a bunch of helper functions to do stuff like parallelization, right? So if you wanted to fetch the user the comment in parallel, you can do that and then pass in a callback function. It'll handle keeping that state of whether all of the requests are finished or not. You can do series, so that's pretty straightforward. The nice thing is that it reduces the indentation. So at least you don't have to make a pyramid. You can just say do this, and then do that, and then do that, and it'll properly handle. It can even properly handle the node convention of the error parameter first. So if there's an error in any case, it won't proceed with the rest. There's stuff like if you want to stat a file, stat a bunch of files. Since that's asynchronous, how do you do that? Since you can't use the built-in map function, the array.map that's built into JavaScript, you can't use that. Same with stuff like filters. So it has helpers for these. So that's a great start. But you notice, if we were writing synchronous code, man, if we were writing synchronous code, it would be almost what we have in our comments, right? I mean, there would be none of this function callback noise. It would be session equals sesstore.get session ID. Then it would be user equals db.get user ID, you know, blah, 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 and you might try cast this whole thing, right? So actually using the features of the language, right? And so this, for me, this has always been the goal. Coming from a bunch of other languages, like, you want to write what your intentions are. You don't want to write boilerplate code to work around that. So that's one thing I found that libraries haven't really helped me with. I showed just one, by the way. Step is another, that's a popular one. It's kind of similar. You say step, and then you pass in a bunch of steps. And you know, you still have to do some stuff like if error, then return, throw. And that's another important point, by the way. Normally, you don't want to do this in regular JavaScript, in Node. And this is a pretty tricky point. Let me explain it. So if I'm writing synchronous code, if I want to get the session from the session store and handle an error like return a 500 response, you know, let's say this is not mine. Let's say I'm not the one implementing this method. It's some library, right? Or it's built with Node or whatever. Since this is an asynchronous method, when the network response returns, it's not coming from my code, it's coming from a low-level HTTP response code. And so the call stack, if it throws an error, that's going to throw back up to the HTTP thing. I won't get the error. So you can't use JavaScript's regular throw. The important point is you need to pass that error to the callback. So if you're writing a function, like let's say I'm making my own asynchronous HTTP GET function. Let's say I take a URL. If it's a synchronous thing, it's pretty easy. I can just do my code, and if it throws an error, it throws it. Maybe I can even try catch something, and I can explicitly throw that error, right? Or throw some error. That's fine. But when it's an asynchronous method, just like we talked about, I can't do that. So if it's asynchronous, I'm going to be taking a callback parameter, right? You'll often see that abbreviated as CD. So I'll want to do something, and if there's an error, I want to call that callback with that error. Otherwise, I want to call, the callback with the null error. So that's a really important point if you're writing asynchronous functions that other people are going to be using. You can't throw that error. And so that's another tricky part of this, is that really everything you do in this callback should be try-caught if you want to be really robust, because you want to make sure that whatever error happens, the callback gets it. Right? In this case, the callback needs to get any error. So that's another robustness thing that if you're writing this kind of stuff by hand, you can't do. So that's one thing that Step takes care of nicely, is that if you haven't thrown any error, it'll properly propagate that error up the callback chain. And it has stuff for doing stuff in parallel. Because Step sets something to this that provides some helper methods, so you can say this.parallel, that returns a callback, and this returns a callback, and it'll keep track of managing state and all that. But ultimately, like I said, ultimately this is still this is a lot of boilerplate code to just say I want to do these things in parallel and then show something, right? So the thing I discovered about a year and a half ago, and that we've been using in production for a year and we absolutely love, is this tool by this fellow from France, this really bright developer from France, called Streamline.js. And his intro blog post, he links to it. I highly recommend reading it. It's this great thing. It walks through exactly this problem of take someone who's a Python developer, right? And he wants to learn Node. Here's how you might implement a disk usage method in Python, which is all synchronous. You say, give me a path, and if that path is a file, then I initialize total 0. If that path is a file, I just read the length of the file. Otherwise, if it's a directory, I enumerate its files, and then I recursively call myself on those files, summing up the total, and then I return the total, right? So the algorithm is the code. Very straightforward, right? And so if you want to transform this to asynchronous JavaScript, here's his first stab at it, right? Way way trickier, and like he has to do all this stuff, if error callback, error return, and this nesting of pyramids, and he's not sure, like, you know, he has all these annotations, like, he's not sure, like, can you even like loop like this synchronously? You surely can't loop like that. How are you supposed to do branching correctly? And you want to ultimately call back with total, but at what point do you actually pass that callback? So his blog post works through all this stuff and arrives at like the patterns that everyone else arrives at in doing asynchronous JavaScript. So for example, like in async for each, he realizes that what you really have to do is keep track, make a function and keep track of a counter and use like tail recursion and increment the counter each time, and until you get to the end condition, and then you call the next, like the finish function. So he made a helper for that, where async for each, you take an array and the iteration function and then the finally function, like the continue function or whatever you want to call it. So he develops all these patterns, and he realizes that it's all this like boilerplate code. And so what he then did was he took Mozilla's JavaScript parser called Narcissus, or it was written by Brendan Eich. It's a JavaScript parser in JavaScript that was developed at Mozilla, and it's used as the model implementation of Harmony, the next version of JavaScript. So he took that and he said, okay, cool. What if I could actually write my JavaScript in a synchronous way, and I'll replace all callbacks with an underscore, and now I'll take this parser, it'll parse the JavaScript syntax tree, and wherever it sees this kind of placeholder callback, it'll do a boilerplate transformation to change that to an asynchronous callback thing. So here's an example. You have a function called archive orders, takes a date, and it's an asynchronous function. And so here's the callback placeholder. That you pass the callback function, and it'll ultimately call your callback, right? So the first asynchronous step is it has to connect to the database. So that's asynchronous, right? Then it's going to query, it's going to make some query. That's asynchronous. And then it's going to iterate over all the results and do two more asynchronous queries or mutations or whatever you want to call it. And when that's finished, it's going to call so.log something, and then there's an implicit return, just like a JavaScript implicit return, and that's when your callback will be called. So the key point is that this is almost exactly the synchronous version of that code. The only difference is wherever you make an asynchronous call, instead of passing a callback function, you pass this placeholder thing called underscore, and it'll transform it to the right asynchronous code, which is saying archive orders is date, and it takes date and callback. The first step is it connects to the database, which takes a callback argument, and if there's an error, then it'll immediately call your callback with that error return. Otherwise, you have a connection, and then it'll query that. And if that query fails, it'll properly propagate the error. Otherwise, it'll iterate over all your orders and do those serialized calls, right? Like this, if there's an error, propagate, then this, if there's no propagate, blah, blah. And then finally, it'll console.log and call your callback. So this tool is called Streamline.js, and I've come to really love it way more than any other library because it works at a language level. It actually lets you use stuff like try catch. So we can actually show this in practice. So the way Streamline works is you just name your files with an underscore JS instead of regular JS. So let's start with a really simple example. Let's say I want to write a function called delay greet, right? And since it's an asynchronous function, it'll take callback, and I'll just do a set timeout where I'll console.log hello, and then I'll call the callback, and I'll do this after a second, right? And so now if I want to say hello, and then once that's done, say world, this is regular JavaScript. Can everybody see that okay? Okay. So now if I run it as regular Node, it'll wait a second, say hello, and immediately say hello. But the cool thing is, I could write that in a synchronous way. So in fact, let's do this. Let's say set timeout. This is really a callback. It's an asynchronous thing. And so after that's done, then I want to say console.log hello. And here, I want to call delay greet, and after that's done, console.log hello. So far, does that make sense? My transformation. And so if I transform that with Streamline before running it, same result. And so if I compile that, this is the compiled thing. And believe me, this code looks scary, but it's really super robust. This is like battle tested to even do like the stack traces properly. This is another really beautiful part. Let me show
So
that.
the comments with the number linked back to your original.
Yep, this is the default. Streamline has a few modes of outputting. This is the default mode, which is it keeps the code pretty printed, or if you can call that pretty, but it outputs comments for the source line number that each generated, like each original line came from. So that way, if you're walking through this, you can find out, like if the error was line 21 on the generated JavaScript, you can see, oh, that's line 6. So in fact, is it delay greet? Line 6, yep, delay greet. Cool, right? So I'll show you another.
The line 2 is in there twice because it had to reorder stuff or intersperse.
Line 2 is there twice because this will actually break down into multiple lines of Streamline. So in fact, we can look at that. Set timeout, placeholder for 1,000 seconds. So here's the set timeout, and then here's 1,000 seconds. So here's another really cool feature. If I throw an error, and I try to catch it, sorry for this part. Error case. Oops. Okay. Oh, sorry, I just compiled it. Anyway, so I'll just run the compiled JS. So cool. So my hello got logged, and then I threw an error, so I can use the natural language of language feature of throw, and I can use the natural language feature of try catch, handle that, and still do something else. But the compiled JS, if I search for throw in here, there's no throw. If I search for try, it's just a function. Because you don't want to be throwing asynchronous JavaScript. So it handles this beautifully. It does the I'm calling some asynchronous function delay greet, but here's my error case that I want to console.log the error. Otherwise, I want to continue console.log. So I know this code looks super scary, but it's really, really robust. And one of the best features is that in an application, if an error is thrown, it'll actually transform the stack trace at runtime also to show the asynchronous version. Because let me show you what regular Node stack traces look like. Let's take the same hello world example that was on the home page. And let's say we have an error on the request handler, right? So the server's running. We'll switch back to our thing. Here's the stack trace in Node. It's served out anonymous, came from emit, HTTP plus oncoming, HTTP. Ultimately, it's coming from a TCP read, right? Where what I'm really interested in is if what kicked off that TCP read? In this case, it was user, but what if it was my own HTTP request to a database, right? So Streamline will beautifully transform that into showing that this error, it actually came from this asynchronous call date. So So that's Streamline at a super simple level, but it does a lot more. It does a lot more cool stuff. Like I can actually, do loops properly. So if I want to loop 10 times, say hello 10 times, and wait a second between each one. Sorry, I got a syntax error. Oops. What am I missing, guys? I'm missing something called line 6. Line 6.
I use 0 instead of less than.
Thank you. Sorry. I should read the error message. So I can use like a feature of the language, a for loop, and it'll automatically take care of transforming that into the right, like call this function, then when that's finished, call this function, and when that's finished, call the next function. So that's really cool because, with asynchronous stuff, loops are.
So they do a parallel for?
Yes, absolutely. So Streamline is really, I should say, it's super minimal. It doesn't try to solve a lot of problems. It says, I'm only going to solve the callback problem. Wherever you want to use an asynchronous function, you want to write your code in a synchronous way, I'll just transform that to be synchronous. By default, that's all it does. But it does have one feature for parallelization, which is really useful, which is a great kind of open-ended thing, which is that if I, okay, let me illustrate it this way. How about I return hello here, and if I console.log delay greet, and I call it like synchronously, you would expect this to output hello, right? But if I don't pass in the callback, did everyone catch that? I just removed the callback parameter from hello greet, from delay greet. So Streamline does two things, by the way. In function declarations, if the function has a underscore parameter, it'll say, I'll transform the body of this function to be asynchronous. If it has an underscore parameter, that's the developer's way of saying that the body of this function is written in a synchronous style, but it's really asynchronous, right? And that's one thing, and the other thing it does is not function declaration, but function calls. If a function call has the underscore parameter, that's the developer's way of saying, this is actually an asynchronous function, but I want you to treat it like a synchronous one because I really want to be able to just write it in a synchronous way, and then whatever comes afterwards should execute after the asynchronous function is complete. So does everyone understand those two things? Like, if you're declaring asynchronous functions, you can write them in a synchronous way. If you're calling asynchronous functions, you can write that in a synchronous way. So here, if I call a function without passing the callback, Streamline won't transform this at all, because this is just a regular function call. But one really cool thing it does is, since this function is transformed by Streamline, it does this really cool thing where if it doesn't get the callback parameter, it's going to return what's called a future. So if I console.log that, sorry, this is weird. So if I console.log that, you see what it returns to the function. So what does that function do? Let's save it. So let's log it to string instead, for starters. And so here's the function it returns. This is the key clause. It says q.push something. So the function returns, you can see it takes an underscore parameter. And then it says, it has some variable that we don't see here called done. But if done is set, then it'll immediately call that parameter with the error in the result. Otherwise, it'll save our callback somewhere. And so this is a really cool thing we can do, which is, let's say we want to wait another second. So let's say, delay greet. This is immediately executing. We didn't wait. Then we'll wait a second. and then we'll call f with the parameter. So now, we immediately executed that and got back this function, and then when we called it with an underscore, then we got the return value. So I called it f because that concept is called a future, and it's really brilliant. It says, if you give me a callback when you call this, I'll treat it asynchronously, but if you don't give it to me, I'll give you back a function that then you can later call when you want the actual value. And so here, we waited a second, but let's not even wait. Let's go ahead and call it right away, and we'll get the same result. So it'll wait for it. And likewise, we can even wait longer. We can wait 3 seconds. 1, 2, 3. And that's a cool thing you can do. So now if we want to parallelize two things, it's pretty simple. We'll make two futures. And now we can, so another way of looking at this is we're going to kick off both these asynchronous functions together. Then we'll wait for both of them to finish. Or if we want to just wait for one of them to finish, we can do that. But so, again, we're kicking off this one, then immediately kicking off this one. We're not passing an underscore, so that's not going to wait for those to finish. But we saved those futures that we got back, and we'll wait for those to finish after that. So now if we run this, we've kicked off two asynchronous tasks and waited for both of them to finish. And so we can even do something like, instead of an exact second, I don't know, let's say some fraction of 10 seconds for both calls. So one of them will take longer than the other. That's all right, we'll wait for both of them to finish. Oh, in this case, the first one finished before the second one, so we could do it another way. We could do the result of the first one and the result of the second one if we want to wait for both before continuing. And now, they're waiting different amount of times, but we want to wait for both of them to finish. And
Can you tag those results so we can tell them apart?
Sure. Yeah, great. In fact, I can even say, let's save this to a variable. And we'll say waiting to milliseconds. And then we'll say,
In your consoles, can you just put console R1 and R2 as strings?
yep. All right. Oh, I should give people a chance to check out the code. Does that make sense? So our delay greeting will make a random number. We'll log how much we're going to wait this time. Wait that much amount of time, the return below. Then we'll do that twice, kick it off. Wait for both those to finish. And as those are running, we should see, before both those start running, we'll see that. But then when both those finish, we'll see this order. So one's going to wait 2 seconds, and one's going to wait 4 seconds. So we're going to wait the longer of those two, 4 seconds, before we show both outputs. That's parallelization. And you can do some cool stuff here. So So, if you guys are familiar with Node or not familiar with Node, I mentioned there's this module system, right? So if you want to use Streamline programmatically, like if you want to programmatically compile Streamline code, you can do that. You generally don't need to. But like I said, Streamline at its core is very minimal and elegant. Like everything I've shown you, that's pretty much all it is. But it has helper like utilities if you want to do some other stuff. So one, what I showed you was I did the F1 and F2 manually, but realistically you probably have like an array of users or an array of comments or something you want to process. You can't just write trivially like user 1, user 2, user 3. You have an array, and so let's do this. Let's say I want to process 5 people, and so for each one, let's say I wanted to call it delay green, right? Let's even expand this to give it a name. So I can say that, and I want to kick them off in parallel, and I want to save the futures. So I can just do futures push, that, and now I can get back the results with this utility called flows.collect. And now I can talk about the results. So we'll walk through this real quick. So we have the same delay greet function. We just added a name that we add. Okay? And I'm going to make an array. This is an empty array, but it could be users, right? I'm not actually using the values in this array in this example, but imagine there were users or comments or whatever you have. I'll make an array to collect all the futures. I'm going to iterate over the array. I'm going to kick off each task and save the future into that array. Once that's done, all the asynchronous tasks have been kicked off. They're all waiting different amount of times, maybe, right? We don't know what order. But then, so I have this array of futures, and then I use utility to go ahead and call all of them and gather them into an array of the results, which will be an array, array where each element is the string hello, and I'll just log that. Maybe I can even return something like I plus hello. All right. So we run this. Each of them are waiting a different amount of time. The maximum is like 6.5 seconds, so we expect to wait 6.5 seconds. And I messed up the JavaScript closure bug, so that's my bad. Man, JavaScript closures, they always trip me up. Yes, that should be name. Sorry. That wasn't even a closure bug, that was a typo. So we're going to wait 10 seconds. But you can see this is really cool, right? We've kicked off a variable number of tasks in parallel, waited for all of them to finish, and gathered all the results. So that's one really useful feature of Streamline. So that's Streamline at a basic level, and I can tell you I've been using this in production for over a year. It's like the best thing ever in my mind, because it's pretty much the holy grail in my mind, because it's better than any other library tool because it just eliminates all noise except these little underscores. But that's like, if that's the only thing that's noise, that's awesome. And plus, it's kind of nice because then it's explicit what's asynchronous versus what's synchronous. But I love it because it actually lets me use language features like for loops and try catch and even switch cases, all that sort of stuff. I should mention one last really cool thing is that. So I showed you compiling. Compiling this thing to JavaScript, right? This is the default mode where it works in any JavaScript runtime because it uses strict callbacks. But there's this really cool thing that this other fellow has built called Fibers, which V8 added support for recently. It's hard to describe exactly what this is, but basically instead of using callbacks, V8 and Node now support the notion of having like a particular stack literally be paused but remembered. So you don't have to have callbacks, but you can continue that stack. It's not threads, it's still single threaded, it's still event loop, but just basically remembers that stacks are created, they're paused because you're waiting for an HTTP request to return, but then resume from that stack. And so this guy worked together with the Streamline author to make a mode for Fibers, which is just beautiful. Where did it go? All right. Here's the Fibers version. It looks pretty darn similar to the original one. I mean, it adds a long line at the top so that the lines are preserved with a bunch of helpers that it needs or whatever. But ultimately, here's my function delay greet. There's a start that. Same exact thing, and the only thing is wherever I make an asynchronous call, it just tweaks that just a little bit to use its helper, like to invoke that thing. But otherwise, lines are identical, right? And that's really cool from a debugging perspective, but also from a performance perspective. V8 now handles this kind of logic natively with this library, and it's just beautiful. So this is, I'm a big fan of this tool. And I thought maybe if you guys are going to learn Node or do some asynchronous JavaScript, I highly recommend it. I think it's super useful.
You said you've been using it for a year in production?
Yeah.
Where is that being used?
So I'm the co-founder of the startup called The Thingdom. We're a social network around products, so kind of like Foursquare or whatever, except instead of places, people are connecting around the things in their lives that they're passionate about, that they love. So it's kind of like, you can think of it like an Amazon wish list meets Facebook or something like that. But this is actually a great example because it's built in Node, and so we have to do stuff like, on every request, if there's a session, we hit our database to get the current user. Then, if you're showing my profile page and you're the current user, we want to hit the database to get all my stuff, but then once you have all my stuff, we want to understand your relationship to that stuff, so we can put little flags there and all this sort of stuff. And so that's, a bunch of asynchronous stuff together, and some of it's parallelized, some of it needs to be serialized, and Streamline just makes that really, really solid.
So after you load the page, if you're looking at my profile page and you see all my stuff, there's an asynchronous JavaScript callback that's happening that you're then getting the information about you, and then you're updating the DOM with elements?
No, this is actually all on the server side.
Oh, okay.
This is just to generate the basic HTML and markup. So it's kind of like, Facebook does a lot of rendering on the client side now.
Mm-hmm.
Actually, Twitter's a great example, right? Twitter shifted back to rendering on the server side for the main feed. But that's a good example. So for your timeline, for your homepage, they first, they need to fetch your user object probably. Then they need to fetch like all of the events shown in your feed. But then once that's set, maybe they also need to then query which of those have you retweeted already, so they'll show the retweet flag, which of them have you favorited, that sort of stuff. And so those are some asynchronous calls being in parallel, some are serialized, but that's the kind of thing that in Node land, that sort of stuff is like particularly tricky to do with that tools like this. And I find that Streamline just lets you write exactly the algorithm you have in mind. You don't have to write any boilerplate code. Cool. So, any questions?
That's cool. Thank you.
Yeah.
So, for everyone in the room, if anyone's interested, after lunch I was going to do a talk on cloud stuff, but I've been doing a lot of work with Node myself on Windows and Windows Azure. If you guys are interested, I'd love to talk about that and show you how it works. It's pretty much similar. I mean, all the tooling is very easy to use. It's just the same stuff. It's just the same code using the other platforms. If you guys are interested, I have a talk lined up after lunch, 3 o'clock. I think in this room too, either this one or the one next door.
Cool. Well, thanks, guys. My name's Asim again, Asim K. Grab me afterwards if you have any questions, whatever.